Hello, good day. First, sorry, been a long year. Not a long year, but how would I put this? It's been a long time. Mm, the year has not been good to me or my family and friends, but I'm pushing on. Secondly, I would like to say thank you to the people who watched this video. I don't think this was supposed to be something that people watch. It was supposed to be something that I will go back to and read or listen to what I what I was saying, whether it's correct or not. And if I blunder, I blunder. It's supposed to be just for me, and I see that people do listen to it. So thanks to those who do, and those who like and those who don't like. You know what I mean? Yeah. So I'm reading, as you know, about Linux and trying to understand how the kernel works and OS in general. And if you know anything about the Linux kernel, it's written in C, the majority of it. And this dude has opinions and thoughts about coding styles, right? And this is what I'm gonna go over today. It's just a reading about his thought on programming style, right? Syntaxes, variable names, as you see. These are the things I'm more interested in, right? Variable name as such. These are the things I'm interested in for today, so it should be short, I think. If you don't know who Rob Pike is, he is one of the creators of Plan 9 and contributors of, or creator of Go, right? This is the dude right here. Great guy. Great great speeches and lectures on the Go programming language, as you can see. All right, moving on. All right, so here he has his opinions, right? Let's start with variable names. Variable names. Length is not a virtue in a name. Clarity of expression is. A global variable, rarely used, may deserve a long name. Max physical address is an example. An array index used on every line of a loop need not be named any more than an I. Saying index or element number is more to type and obscures the details of the computation. So, I think the example is this is self-explanatory, right? Like, as a programmer, we understand I equals 0 to 100, and then you place it in an as a subscript or index into an array. This just means, hey, I is just an index. We don't care about anything it does, right? All we know is that in an array at this point or this element, we want to put a 0 in there. So whether we call it X or index or element number, it doesn't matter. It makes people even fixated on what these are, as opposed to what this is meant to do, right? And you can see that there's a difference between me. I think this is a bias because I've been doing this a bit longer, and this makes sense. This, after looking at it for the first time, I was trying to understand what the hell is this, and I guess that's what he's trying to say, right here. By adding this, you've added a cognitive load to me to keep in my mind what this is. Again, bias, because I've been doing it this way for a long time, right? All right, so moving forward. When the variable names are huge, it's harder to see what's going on. Yeah, this is partly a typographical issue, right? So it gives you this example. The problem gets worse fast with real example. Indices are just notations, so treat them as such. Pointers also require sensible notation. NP, okay, this is where it starts getting a little, not confusing, but okay, let's just go. You know what I mean? MP is just a mnemonic as is just as mnemonic as node pointer. If you consistently use a naming convention from which NP means node pointer, you can just easily derive that. So like I said, here I'm able to understand that I is nothing but an index, and that's that, right? So if people in our organization start using this as a mnemonic for node pointer, we just begin to treat it as I, correct? That's what he's saying here. Agreeable to this point. More on this in the next essay. As in all other aspects of readable programming, consistency is more important in naming. If you call one variable max physical odd, don't call its cousin lowest address. Why? Because now you're like, where are we, right? You can see the difference, right? This, I assume he means just take this E or ESS out. Finally, I prefer minimum length but maximum information names, and then let the context fill in the rest. Globals, meaning global variables, for instance, typically have little context when they are used, so their names need to be relatively evocative. So I say max physical address, not maximum physical address for a global variable. But MP, not this whole thing. So MP, and not this whole thing for a pointer locally defined and used. So I guess you can think about it as if you're using something everywhere, you better name it so I can remember. However, if you have a function, right? If you have a function and you have, let's say, a variable in that function that doesn't bleed out to other things, then you can call it something short, right? So that's why he said, but NP and not node pointer for a pointer locally defined and used, right? This is important. This largely is a matter of taste, and taste is relevant to clarity, right? Yeah, but I agree with him 100% on this. If you're not using it anywhere but in that function, you can call it something, that akins to what it's supposed to mean. Okay, so here is the confusing part. C is the use of pointers. C is unusual in that it allows pointers to point to anything. Pointers are sharp tools, and like any such tool, used well, they can be delightfully productive, but used badly, they can do great damage. He talks about his little thumb thing. Yeah, had an injury or something. Pointers have a bad reputation in academia because they are considered too dangerous and dirty in some ways, I guess. But I think they are powerful notations, which means they can help us express ourselves clearly. Consider an example. When you have a pointer to an object, it is a name for exactly that object and no other. That sounds trivial, but look at the following two expressions. You have NP, which, as you know, we've established, or he has established that NP just means what? Node pointer, right? That's set in stone. Now, after looking at it 1, 2, 3 times, I understand what he's saying. NP, I've already associated that to a node pointer. And then you have this object called node, and it has this index of I. I understand that because, it's just like the first one right here. All right, cool. The first points to a node. The second evaluates to the same node, right? So you have to keep in mind that with this one, you're just pointing to the node, right? The node might be a linked list, right? Think about it that way. Or an index into an array. Think about it that way. So an example would be this. So we have argv. Cool. So let's say we create a child pointer MP, and it's gonna point to arg this guy, right? So that's MP, right? And then now the same thing would be you had argv pointing to, let's say we have int I, well, actually we do have n flag, something like that. You know what I mean? So these are, think about this guys as this too. MP as MP pointer to, this is just a pointer to this, right? And then this is the same thing as this. Cool. All right. As he says, the first points to a node, the second evaluates to the same node. So they're all pointing to the same thing. So think about this as 0, this is pointing to the first, and this is just pointing to the beginning of that node. But the second form is an expression. It is not so simple. To interpret it, we must know what node is. Now, this is where I'm getting a little lost, right? What I is, and that I and node are related by the rules of the surrounding program. Now, I can do the same thing, right? I think, right? I can say now you have I, right? And now you have K and also J, correct? It's going to be the same thing as they're pointing to different places. That's my thought. I may be wrong, totally wrong. Nothing about the expression in isolation can show that I is a valid index of node, let alone the index of the element that we want. If I and J and K are all indices into the node array, it's very easy to slip up, and the compiler cannot help. So that's why, hence my reason, right? Like this can be a pointer to anything. It can be a pointer, well, it can only, I guess you can only be a pointer to that, I guess. You can only point it to, let's say 0. Would that even work? Yeah. So it's actually working, right? So you can have 1, whatever, pointed to that, and they're all the same, right? You're doing the same thing. So I don't understand what the argument is here. So it's a little confusing to me, right? Because you can point to whatever part of this character, right? You can point to different indexes using the same pointer. You know what I mean? So that's why I start to lose understanding. It's particularly easy to make mistakes when passing things to a subroutine. I agree with that 100%. So if I were to create, let's say we have different functions, f, and this function, well, not that way. Actually, I can do that, right? Let's say we have f and g, right? And g just takes a pointer, mp, and this takes the same thing, let's call it arg b, and it has an index, call it I, right? So here's the problem that he has with this thing, right? So he's saying that it's particularly, where am I? Yeah, here. It's particularly easy to make mistakes when passing things to subroutines, right? So we know that this exists in the main function. Imagine that we start calling f and calling g. It will be very, very easy to just pass the pointer, right? Just give it that reference. Versus I have to give it that array and also the index and hope to God that it's the right index, right? Or not overflowing or whatever, right? So that is important. A pointer is a single thing, and an array and an index must be believed to belong together in the receiving subroutine. An expression that evaluates to an object is inherently more subtle and error prone than the address of that object. Correct use of pointers can simplify code. So this is where I'm like, what are you talking about here? I am not really good with C. So okay, you have a parent, and then you have this. Let's say node I equal dot type, right? Why is it? Why do we need this? Why do we need this bit? You can just eschew this. You can actually just take this. I'm not sure, but like I said, these are places where I'm like, what are you talking about, right? Because I'm not good at this. Skill issue, by the way. I'm not scared to say it. I'm I'm not good at it. So yeah, so why is this not the only thing you just need? This bit, right? So he's saying, look at this shit versus look at this shit. And from the way he puts it, this looks like shit, right? This looks beautiful, looks easy and all that. If we want the next element's type, it's just this. Look at this mess. But when you look at his own, he's like, hey, look at this. Look at this. Easy, right? So that's cool. But yeah, if you get what I mean, like this is where I start to get like confused, because we really don't need this. But maybe this is not the point. This may be the point, I guess. But yeah, whatever. Now, like I said, if you know, by the way, if you guys, 2-3 of you guys know what the hell this is, that'd be great explaining. Thank you. And hopefully I'll get the time and the zeal to keep doing this more frequent as I deal with whatever I have personally, right? Like, yeah, it's been a heavy year, but I would chug on and keep moving on. All right. Thank you, mate. And see you on another one.